Good morning, everyone. Can everyone hear me?
Good morning, Puneet.
Good morning.
Yes, good morning, Puneet.
Good morning.
We'll wait as usual for a few more minutes for people to join in. In the meanwhile, I hope everyone is doing good, practicing enough to start their Python journey. Any major questions or roadblocks that you guys are facing towards your practicing with Python? Are you feeling more confident, more comfortable in coming days? How is it? Share the screen. All right, guys, let's begin. I think we have already 5 minutes spent on it. All right, so far, we have seen is how the Python primarily works. What are the important components when we talk about the programming language? The last session was more brief towards how do you utilize an external library called pandas, which helps you read the data which is in the tabular format, and what are the different operations that you can perform on it, such as group by or finding different sections of rows and columns, right? What we are going to start today is a very important aspect of data analytics or a data science in a broad way, and that is what we call the data visualization. Okay, data visualization has a very important role to play, no matter big or how big or how small organization you might work for, as a data analytics or data scientist. But data science has evolved in a very great way with data visualization, right? Some of the interesting things that has happened in last couple of years, maybe or 5 years, is there are new job profiles, though those got created because of data visualization. We never had earlier a position called data visualization head, or we can say a data visualizer, or a ClickSense designer, or Power BI designer, right? Those are nothing but the people who knows how to do a data visualization in a most efficient way. Okay. So what do you mean by data visualization? Okay. So it's a very simple field in a way which allows or which helps you to visualize your data, visualize the story behind your data in a most graphical or most user-friendly way. Okay. Imagine you want to, showcase the findings of your EDA or exploratory data analysis that you did on any data set, and you want to showcase that to your stakeholders, let's say CEO. Do you really believe he might have, the time to read all the PPT or PDF that you might have created? Well, absolutely, he doesn't have time. The second, he doesn't have an interest in reading those PPTs. Okay, so what we generally do is we showcase the same information but in a more pictorial way, right? So that once you just look at the diagram, just you look at the chart, the most information or the most detailed information can be popped out without even writing a single word. So that is what we are going to see today, and how to do it in Python. Okay, so Python has two most powerful visualization library. Okay, so we're going to see today. So have everybody opened this day 5 visualization for company stakeholders opened in their Jupyter notebook? Can we quickly open that? Yes, have we all opened it? Cool. So let's start into it and see what we need to do. So you have been hired by the stakeholders of Dream Housing Finance Company to help them get the visual insights on the company's operations. Okay. Using the data visualization technique that you might have learned. Okay. You have to help the data visualize the data and see if you can help the stakeholders arrive at some inference based on this visual plots. Okay, so as I said earlier, the visualization helps people understand the story without even writing any word. Okay, what is the data set we are going to use? So if you look at the data 5 folder, so if you come to your Basecamp, if I go to day 5, there should be again two folders. One is data, where you have a data.csv, and the notebook. Okay. The data that we're going to talk about is more of, again, the same data. I think we used it last time. It is more of a loan application data set where I have 614 records and I have 13 columns. Okay. So loan ID, every application has a loan ID, right? So loan ID, gender, married, dependents, education, self-employed, and so forth. So these are 13 columns that I have, and I have 614 total records. And this is the snippet of the data, right? Why should we solve this project? Okay. After completing this project, you will have a better understanding of data visualization techniques. So in this project, you will be applying the following concepts: bar plotting, scatter plotting, KD plotting, that's kernel density plotting, subplots, and excess modification, right? So these are the couple of things that will give you a good understanding of how the visualization generally, makes a place in Python, right? So before we move on, have anybody done, visualization in their career before? Maybe in Python, outside Python, has any experience with visualization? Okay. So majority people have not done it. Okay, in Java, that's interesting. Okay, Jayavardhan have done it. Cool. All right, no worries. So majority for you is kind of a new thing. Okay, Shiva Lakshmi has done in Power BI. Good. Matplotlib. All right, cool. Cool. So let's start with the first task. All right. So let's start with the simple task of visualizing the company's record with respect to the loan approvals. Okay. So we have seen the data, like we have the loan approval, loan status is in YN, right? The path to the data set has been stored in a variable called path. Load the data frame using pd.read_csv, which we have seen in the last lecture, and store the data frame in a variable called data. Save the counts of a loan status in a variable called loan status using value counts. Okay. So basically you have to use a function called value counts, which will allow you to count the unique number of categories and corresponding count in the column loan status. And then you have to plot the bar graph, right? So some of this task we can do it already because we know how the pandas work and how the data frame can be read in. Can we quickly try, guys? Can we quickly try reading the data frame in pandas? Can we see if we can reach at least to this point, the third one? Yeah, guys, any success? Anyone read the data completely? Okay, that's cool. That's cool. That's very well. Okay. Anyone else? Have we finished it? Okay, awesome. Now let's look at it how we can do it. So traditionally what we have been doing it is we have been reading the libraries in the first cell that starts our solution, right? So import OS, import pandas as PD. We will need pandas because we are going to store the data into the format of data frame. We need NumPy for doing our mathematical calculations. And one of the oldest library for visualization in Python is called matplotlib. Okay, this has been inspired from the tool called matplot. Okay, so matplotlib is the library that is created only for Python. Okay, so out of matplotlib, we are going to use a pyplot package. So that stands for Python plot. Okay, so import matplotlib.pyplot as PLT. Okay, so this is one of the library we are going to see and utilize to make the visualization. You might ask, is that the only library I have for visualization in Python? So no, there are few more. All right, there are few more. Let me just give you some names. So one is Cbond, second is Plotly. Okay, these are another two libraries which are very powerful. These are newly created libraries in Python for visualization. However, the oldest one is the Matplotlib. Okay, Cbond is made on the top of Matplotlib, so a lot of function overlaps you will see between that two. Okay, so yeah, coming back to the solution, traditionally we will read all the libraries that we need. Okay, somebody was asking me, why do we need OS? I mean, in this particular solution we don't need it, but there are a lot of operations related to the folder management or switching between the folders and selecting the file is provided by the OS. So I can just say os.list_dir. So it will just show me all the contents that is available in my current directory. Okay. All right. As per the task, we have to store the path variable where we have the actual location of the file, the data.csv. I will quickly read pd.readcsv into the data. And then in order for me to in order for me to calculate the distinct categories with its appropriate count, I can use a function which is inbuilt function dot value counts. But where do I apply this value counts? I would apply on the column that I want to calculate. So I simply said data, that is the data frame object, loan status, that is the column for which I want to see the value count. So I just said data loan status dot value count. And if I print this now, print loan status. So let's see what happens. So if you see here, I get this two rows, Y and what is Y and N? Yeah, what is Y and N?
Values.
So those are the unique categories I have available in the column called loan status. And what is this 415185? It simply tells me that Y category has 450 instances, N category has 185 instances. Okay, so value count helped me quickly realize the number of unique categories as well as the value associated with it. There are a few more functions that I can tell you, which is very handy, which we will maybe see it in the next session as well. But let me give you. Let's say you want to see how many unique values do you have. So you can simply say n unique. So if you see 2, why I get 2? Because I have a 2 unique values, y and n, correct? So that's why I get 2 unique values. Similarly, if I say unique, so I get the actual unique values, y and n. Is it correct? Is what I'm trying to do. I can say gender. So if you see, I get 3 values, female, male, and n. And if I say n unique, I would get 2, right? So there's just another functions that we will see it in the EDA as well. Okay. So the point of saying is value count is probably used for getting the unique categories with the associated values. Now the next task that we had was to plot a bar graph out of this loan status column. Okay. And the things to ponder upon is company has more loan approvals or loan disapprovals. And then can one of the company's health factors to be its own loan status distribution. Okay. So what I simply did is PLT. So what is PLT? PLT is nothing but a reference to matplotlib py plot. Okay. So I'm simply saying PLT dot bar. Why bar? Because we want to put up a bar graph. All right. So PLT dot the type of graph that you want to render. Okay. If you want to render scatter plot, you can just say scatter. If I want to plot a bar, I would simply say bar. Correct. Now, every graph or every visualization has its own set of inputs to take in. Okay. So what I mean by that is, for example, I'm sure everyone know what is pie chart, right? Everyone knows it, correct? So pie chart does not need an input for x-axis and y-axis because pie chart doesn't have an x-axis, correct? Similarly, bar chart would need x and y axis. Similarly, scatter plot needs x and y axis. So my point of saying is every type of chart or every different type of chart has its own set of inputs. Some of them requires only one input. Some of them requires two inputs. Okay. So in the bar, I would need two things. I would need something to populate on the x-axis, and I will need a data points to plot it on the y-axis. Okay. So if you look at it carefully, I have passed two arguments here. They are separated by comma. Correct. What is on the left of this comma is what I want to see on the x-axis. So what I simply said, loan status dot index. Why index? Because let me check the type of it. So type, what do I get? Series, correct? So series is nothing but a type of a column in the data frame. So what I simply said, loan status dot index. Okay, so that's why I get y and n. And that's because I have put it on the left of the comma. I would get that on the x-axis. What do I want to print on the y-axis? Loan status itself. So this count. Okay. So when I say now that is what I have defined in the bar. Now, if I don't use this plt dot show, for example, let me just do that. I will still get this plot because we are doing this into a Jupyter notebook. Okay. But if I'm not doing this into a Jupyter notebook and doing into some other IDE, I will need to use plt dot show, right, to render this graph on my screen. Otherwise, it will not show up. And if you carefully now look at it, I get two bars, y and n, correct, with the corresponding values. Any quick questions, guys? What we did, how we did, why we did? Guys, any questions? All right. So index is nothing but the name of your rows. Do you recall, Nikhil? Oh, sorry, I'm sorry. Shiva Lakshmi, do you recall when we were looking at the pandas data frame? I said there are two ways you can access the core data. One, you can access it via column. Second, you can access it via rows. Correct?
Yeah,
How do you access the columns? With the name of the columns, correct? Or with
right.
the index positions. So the zero means the first column, isn't it? The first means the second column. Similar
Correct.
to
Yeah.
that, every column has a name, right? Every column has a name. A, B, C, D, or whatever the, like if you see here, we have this column names, loan ID, gender, merit. So I can access these values using these column names. But how do I access a record if I want to? Let's say I want to access this third record. How would I access it?
So using indexes.
Exactly. So that is what we are saying here. Loan status dot index simply means this Y and N because these are the row names that happened.
Okay, got it.
Okay. So if I print index, so when I said loan status dot index, can you see what printed? Y and N because these are the two index positions we have created, and that's what we printed here. Right? Can everybody try printing it on your particular Jupyter Notebook instance? Cool. Can everybody just try to do it on their version of Jupyter Notebook and see if it is working? Anybody facing any issue? Wow, Jayavardhan has already printed the X labels and Y labels. That's good. That's good. That's good. So guys, now point of saying is if if somebody asks you what is the distribution of the loan status in the data set, rather than showcasing these numbers that Y has 415 and N has 185, if I just showcase this even picture, this tells the same story, isn't it? It's far more better to showcase this kind of a story rather than having in this kind of numbers. Okay. So again, bar plot is primarily utilized. All right, before even I get into that, what is more important in any visualization industries, you need to understand at which position you will utilize which graph. Okay. Because do you believe every graph is suitable for every position? Does anybody believe here that you can use any graph for any kind of a data set? Absolutely no. There are typical graphs which you will have to utilize based on the data that you have at your disposal. Okay. If you carefully observe, the bar plots are primarily utilized when you have one as a categorical variable and second as a continuous variable. Are you getting my point? One, if I have a categorical variable, second, I have a continuous variable, I can utilize the bar plot. So you'll have to, remember this. You'll have to make sure that you use a right kind of graph at the right position. Okay. Because not every plot is suitable for every data points. Now let's talk about the second task that we need to do. Everyone needs money. Well, yeah, that's particularly very true. So let's talk about what do I have it here. The company provides financial assistance across the different regions of the country, right? One interesting statistic that stakeholders want to see is the loan approval distribution across the regions. So now I'm interested to look into when I approve the loan, what is the pattern of that approval across the different geographical area, correct? So what I have to do for that is I have to group the data frame by the property area. So we have a column, something called as property area must be here somewhere. Yep, property area. So that basically tells me whether the customer belongs to urban, semi-urban or rural area, right? So I simply have to group the data on that particular column, property area and loan status, right? So I have to group on both loan property area and loan status and store it in the variable called property and loan. Use the dot size method on property and loan and then use unstack to save back to the property and loan. So this is going to be new for you, right? For the first time you're looking into, but that's okay. If you can follow the instruction, it should be pretty much good. All right. So as per the instruction, we have to group by the data on two columns, property area, loan status. Use the size method to identify the number of records. Plot an unstacked bar plot to the property and loan. It is similar to creating a stacked bar plot except the change. So don't worry about this part, right? Don't worry about the last four part. Can we try the first two part quickly? We should be pretty much good now with the first step at least because we have already done it. Can we quickly try, guys? Yep. Anybody got any luck? Wow, that's good. That's good. Everyone got it. Anybody else? Group by dot size. Awesome. Awesome. That's good. That's good. So far, so I think three, four people is done. Come guys, anybody else? Hmm. That's good. Come guys, we have 25 people. Just five people is down. Now six. All right. Cool. So let's look at it how we are planning to do that, right? So the first step is we have to do a group by, right? So we are doing data that is nothing but the name of our data frame. So data dot group by. So when we do a group by on a single column, it's fine if you don't provide it in the list format. But here I'm going to do a group by on two columns. So I have to specifically enclose it within the list comprehension. So I'm using property area in the loan status, right? And I'm storing this entire operation into a variable called property and loan. Okay. And when I say property and loan, so there's something we have to talk about here is what do we mean by size and what do we mean by unstack? Okay. So let me comment this out. So let's talk about first size. Okay. So when I say size, what generally happens in the background is pandas will group by these two records, right? Because the two criteria that we have given, and it will count the number of instances that falls into this group by condition. So for example, when the property area is rural, the loan status is N, how many number of rows that satisfies these two conditions, correct? The second part is what is the number of what is the number of records when the property area is rural and the loan status is Y. So the job of size is to count the number of records that falls under this two group by filters. Okay. And then the last part that we apply is unstack. Okay. Let me show you what unstack does. The job of unstack is to reformation. Okay, you just stack it out. So basically, before doing this, my result where I had two columns, right, of the conditions. But when I apply a stack, right, I get more proper where I have a property area as a rural and I have a NY as a columns now. So if you remember earlier, NY as my rows, now I convert it to a columns. Are we clear what unstack does? Anybody has any question on what is the operation that we do for size and unstack? Yeah, so you tabular format. I'm just saying it is used for a reformation. When you want to convert the column that you had as a rows into a two different columns. Earlier, the loan status was primarily utilized as a rows. Now I'm utilizing it as a column. Okay. Yes, Urmi, it will work. It will work. So that's what we did in property and loan. So now if I print it, a couple of things you should quickly do it is print the property and loan and see how does it look like, right? Can anybody or does anybody have checked what is the type of property and loan? That's a data frame. Did anybody check? Be honest, guys. Did anybody check before they applied any operation further, or they didn't check? Right. So as I've always been saying, you should always check the data that you're working on, right? So you should know that this kind of unstacking or stacking results in a data frame. Okay. Anyways, going forward, we have to plot the data that we have used. So earlier we used a mechanism called plt.bar. Okay. So plt was a reference to my matplotlib pyplot library. There's another way we can do a plotting directly from a data frame is, so that is the name of my data frame, right? Property and loan that we just created. Dot plot. Are you getting my point? So instead of using plt dot plot, I can straightforwardly use the name of my data frame dot plot. That is also fine. Okay. The first argument that I have to give is a kind. What do a kind mean? It simply asks you what type of plot do you want to create? Because in the first instance, we were directly saying plt.bar, correct? So we didn't specifically had to mention what type of graph we are creating because we are saying it outrightly here. But when we say it from the data frame, property and loan dot plot, here I'm not specifying any type of plot that I want to plot, correct? That's why we use an argument called kind is equal to bar. So I want a bar chart. Stacked is equal to false. So I'll show you what stacked equal to stack means. So hold on for that for a moment. And fig size basically tells me what is the size of the graph do you want to visualize. Okay. When I say plot, I should get it in this particular format. So when I said stacked is equal to false, it basically comes out of the two things. Why two things here, guys? Any quick observation here? Why am I getting two outputs for one, like rural to semi-urban to urban to? Any quick idea?
The loan status Y, right?
Exactly. Every column that I have a two values. One values for n, one values for y. So when I say stacked is equal to false, right? It will create two different bars for a one single value. Rural two values, semi-urban two, and urban two. Correct? That's what the stacked true and false means. Fixed size basically tells me what is the size of the entire graph that you want to create. Is it right? So I'm saying 15 by 10. So I'm getting 15 by 10. Okay. Now, every graph that we create, we need to provide a sufficient information on the labels, right? Sufficient information on the x-axis for anyone to understand. Like today, if I just give you this graph, will you be able to tell me what does a rural wheat or what does a semi-urban means? No, right? Because we have no idea what this values belongs to. So it is preemptive or it is important or it is mandatory, I would say in a way, you should provide what are you putting on the x-axis and what are you putting on the y-axis, right? So I can simply say this value belongs to property area. How do we do that in Python? We can simply say PLT, right? So we are saying PLT means again matplotlib dot x label. So it's pretty simple that we are giving a label to the x-axis. So I'm just saying PLT dot x label, and I can write anything that I want. Then property area. Similar to x label, I can say PLT dot y label, and I can say maybe count of loan status. What is x ticks? So PLT dot x ticks rotation 45. So let me remove this first so that I can show you the changes. Right. So if you see now on the x-axis, I have property area. Y-axis, I have a count of loan status. And here I'm, if you can see, this rural, semi-urban, and urban is now in the horizontal way. I have a provision, I can tilt this a bit. So that is why I use PLT dot x tick, and I can say 50 maybe. So it will be turned around by 50 degree. Or I can say maybe 100. So just gone 100 degree, right? So you can move around this ticks or this names to any degree that you want. Okay. Any quick question, guys, what we did on this 4 lines of code? Yep. Any questions, any concerns? Can everybody try doing the same thing in their Jupyter Notebook as well? All right. So PLT, okay, dot plot part. All right. So data frame that we are using, right? So this property and loan is a type of data frame. Is that clear? I mean, till this point, are we clear, Prasad? Okay. So the point of showcasing here is data frame has an inbuilt support for plotting. Okay. It has an inbuilt support. So when we say dot plot internally, it makes a call to plt dot plot only. Okay. Because matplotlib has a dependency on the data frames and vice versa. So if you, I don't know if you have realized this, when you say pip install data frame, sorry, pip install pandas, okay, when you do that, you will realize that matplotlib also gets installed. Now tell me, anybody from here, did we explicitly install matplotlib on our machine? Did we do it? I'm sure nobody has done that explicitly, right? Like pip install matplotlib. Did we do it? Generally, it gets installed with the pandas library that you installed. Okay. So the point of saying is, data frame has a inbuilt dependency on the matplotlib. So when you say data frame dot plot, it makes a call to the inbuilt matplotlib library only. So that's why you get a direct provision of using this kind of a sentence. Now, as you are not explicitly saying what type of a graph do you want to create, that's why you use kind. So kind is equal to bar. Is that clear, Prasad, now? Okay. Somebody asked for fixed size. Guys, fixed size is pretty simple. You just, it is talking about the size of this graph. I say 10 by 10. So do you see my diagram size or my chart size has changed? I can say 5 by 10, right? So 5 is what my length is, 10 is what my width is. Okay, so that's pretty simple. Actually, the stacked is equal to true, false. I'll come to you. We have a different example for to cover that. We have it already, don't worry. But basically, stacked tells you whether do you want this two graph as an individual, or if you remember from our schooling days, we can have a graph on one top of another stack. I can have the values for rural y and n on stacked of each other. So I can just take this and put it on the top of it. I can take this and put on top of it. So if I say stack is, let me do that for you now. What happened here, Akshata? What does happen here? Instead of having two bar plots or bars, I simply had only one. Because I said stacked is equal to true. So it just stacked one on another, right? That's the only difference. Okay. Has everybody finished it, guys? Quickly. Has everybody finished it? Is everybody getting the same output? Anybody who is still not getting the output? Cool. There's one more thing. You can even save this as an image. All right. So I think there is a function called plt.save, if I'm not wrong. And I think I can say mg.jpg. Right. Oops. There's a library. I think I'll save. There's a function called, okay. I'm not getting property and loan. So what is, yeah, save fig. Yeah, thanks Nikhil for that. Save fig. Prasad, I'm sorry, but I'm not getting property and loan is equal to, what is the line before that you have written? Have you done the group by correctly? Prasad, it's not mandatory that plot will have always the three arguments. It depends from where you're calling and how you're calling it. So if you realize, when we were calling it from the matplotlib library, right, you had to provide the x and y axis. Is that right? But when you are calling it from the data frame, right, you're calling it from the, you're calling it with the three argument, like what is the graph that you want, whether do you want stack or whether do you want fixed size. Here I'm explicitly not saying x or y axis because as I'm using it directly on the data frame, it is getting identified internally that what would go on the x and what would go on the y. Because I'm sure, does anybody got in your mind, how does a bar plot knows what should I print on the x-axis and what should I print on the y-axis? Did we explicitly mention it anywhere here? We didn't mention it, right? But Python pandas and matplotlib internally knows that the columns would go on the x-axis and the rows would go on the y-axis. Right? And as Nikhil said, there is a function we can do is plt dot save fig. And I can simply say image dot jpg. So if I say in my this, I would have a image dot jpg. Okay. So I can just go and use this image. Yeah, Nikhil, go ahead.
Um, while saving the image, I kept it as just didn't give any extension name. Okay,
Mm-hmm.
how we gave, but it's stored as a PNG.
Mm-hmm.
Okay, and why? I mean, the Python itself, it is saving that, or is saving have some methodology that automatically it save as a PNG.
So the default would be PNG. That's what I'm saying.
Yeah.
So if you look at it here, if
Mm-hmm.
you look at the function explanation, the doc string, it says it is only expecting ARGS and KRGS. So that means it doesn't have any specific arguments to take in.
Okay. Okay.
So by default, if I don't give an extension, it would go and store as a PNG, maybe the system format that it has.
S- Okay. Coming to this point again, argument you gave it as a image.jpg.
Mhm.
So key argument might be the other format of the file, or it's
No,
like
K.
in.
Okay.
Okay, why? Because I'm getting no value in the image actually. You're getting the blank image.
You're getting the blank image.
Yeah, correct. It is saving that in the name, but it is getting black image.
Mhm. Let me check if I am also getting the blank image
Yeah.
because I also stored it just now. The size is 3 KB, it says. It's a blank image.
Mm, that's my doubt, because if it is calling the function and it's having the default PNG formation, it should save, and the file value is showing is a little bit. It's not 0 byte, right?
So if you see type error, save fig, missing one required positional argument, F name. So by default, we'll have to give a F name, right?
Okay. Mhm.
So let me give the F name as maybe IMG. If I run it now, so figure size is 432 plus 288 with 0 access. If I check it again here, I get a new image with 1 KB, which is again a blank. I think what is happening, maybe I'm guessing or sensing is it because we are not storing anything in PLT?
Oh,
I'm getting my point. Let
okay.
me
Mhm.
check. Not fig.
Sorry, I'm killing your time actually, but
No, no, it's okay. I mean, I understand because what my basic assumption is generally it happens when if you closely observe,
mhm.
we are not storing anything in PLT. So
Correct.
if I print PLT here, PLT, right? So I'm just getting what? A package name here, but I'm
Okay.
not getting any object. Are you getting my point?
Mhm.
So generally, that's why I open the Stack Overflow. What people generally does is they have a figure object created,
Mhm.
and then in that figure they create the plot.
Okay. Okay.
Okay, so I can do something like this. I mean, this should work ideally. I don't know.
Let me try myself as well.
So you just create figure. You
Yep.
created all the plots,
Yep.
and then instead of plot, we are saying fig.save.
Got it. Okay. Got it. Got it.
So if I store it now, okay,
Mm. We are
okay,
getting that blank image, but because you have the plot image over there, right?
So okay, it's getting this one because plotting I have done in the plotting one.
But yes, that's it.
So I can do it something like, oh, no, the plt.plot. Okay, dpi fig.dpi. Save plt.plot. The point is again the same thing. We are doing it in the plotting here.
Hmm.
This one. So this would come under. So now if I do it, oops, again a blank one.
I think, can you try to call save before the plot?
I'm sorry.
Save before the that and then show, because there is some comment in Stack Overflow regarding this. First,
It might happen. It might happen. The problem is I'm just getting a 1 KB image. That's not the right one. I should get a more one.
You open the previous one that you saved. Previous file, old file.
plt.figure property and loan dot plot. plt. Can we do it here to see if that works? Is equal to plt. That's right, correct? See, I think the problem, if you see here, this is getting printed, okay, as a PNG. I think what is happening here, what I'm sensing right is, here I'm directly doing from a plt.bar. So I'm utilizing the inbuilt PLT object for it. However, here I'm utilizing the data frame object for it. So if I just say
Okay.
actually, it worked for me when I tried to save first and then show.
something like this, plt.show.
So I did a plot.save fig.
Acha.
Yeah, and then show. Yeah, now it, so now if you try, it should work.
14 KB now. Now it's up. All right. So what you did is you remove it. Okay. The only problem what I was doing was I was using show before.
Yeah.
Okay. That's why I think it was coming out.
Because we are showing the data before
Yeah, I think it
saving
is.
it.
Yeah, kind of an exit function point for it.
Mhm. Yeah. Okay.
But this is good. Thanks. Yeah. Thanks.
Have
Thank you.
directly Punit,
Yeah.
am I audible? Yeah,
Yeah.
I
Yeah. You
directly
are.
used a savefig image.png, so it is getting saved and I'm able to see also. Just write png after this image, img. Yeah,
PNG.
yeah.
So it's not working. You are saying.
No, it is working.
Python
You
is
have
storing
tried
a.
any save or something.
Yeah.
Yeah.
So I think PNG, JPG both are working perfectly fine.
Hmm.
All right. That's good. That's good. And so just that's the point I was trying to showcase, that you can use or you can save the figure if you want to. Okay. All right. Let's look at the third and then we can maybe break for some time, right? So expensive education. Okay, was there any question? Sanjeev says, how does it recognizes which plot we are talking about to the label? So Sanjeev, we have already created a bar plot here, right? You're using a kind argument. So it knows that you are using a bar plot. I hope I get your question right.
I'm trying to ask that how does it come to know that on which data structure or uh, which data structure, yeah, or which object we need to label it.
So if you see here, we are saying property and loan dot plot. So it knows
Mhm.
which data type we are or which data we are plotting on.
Yeah, but in plot in plt.x label, we nowhere mention property and loan, right? Or
Yeah, that's what I'm
uh,
saying. When you print, okay, let me print this for you. That's the logic I said, right? It knows that the columns I'll have to use as a X label, and the rows that I have here would be goes into the Y label. That's the logic that it works on. And this filter, so this is a filter variable. Have you imagined
yeah,
there
yeah,
cannot be
I
two headers, right?
I got your point, but this PLT, okay, so PLT is not an object, right? It
No,
is just a library, right?
yes.
We are directly calling plt.x label, okay,
Mhm.
but that x label should be applied on which plot or on which object. How does it recognize it? Or is it like that it will take the latest created plot?
That, I mean, that's actually a good question, but we will look at the subplots. Okay.
Mhm.
Then we can answer this question. What happens generally is whatever is the latest that we have created, it will go and do the X label for that. Okay. And how does it know? It's basically, as I said, if you try to call this function, okay, it will go into the plot accessor. It will go back into the matplotlib itself
Mhm.
because it has a dependency on that function. So when I say property loan or any data frame dot plot, internally is going to make a call to this plt dot plot itself because that's the library call is going to make. Okay. So if you check the type of it or if you check the object of this and the one that we created earlier will be one and the same because they are both getting called from the matplotlib library itself.
Mhm.
Okay. And because I'm calling it directly from the matplotlib library, I know that I can use this function because it also comes from the same library itself, plot.x label.
Okay. So when we are dealing with like multiple plots, so like, is there a way to identify that
Exactly.
with?
There are ways. There are ways. In
Okay,
the
okay.
last example that we have for
Mhm.
today, in the last example, we are going to talk about how do you create these three different graphs.
Okay, okay.
And when you create three different graph, it is quite obvious that your axis would be different in all three. Correct. Your x-axis would be different, maybe y different. You want to give a different titles. So yes, there is absolutely a way you can manage these three things. That's why I said when we will come to that point, we
Yeah.
can talk more about
Thank
it.
Yeah, thanks.
Yeah, yeah, sure. Okay. Expensive education, right? So again, higher education has always been an expensive endeavor for people, but it results in a better career opportunities and stability in life. But does a higher education result in a better guarantee in issuing the loans? So just trying to find out the relationship between the education and the loan, would you get it or not? Okay. When before that, have anybody tried interpreting this graph? I mean, we carried away with the save fig option, but did we interpret this graph that majoritarily we are approving the loan because the Y graph is up and we are more active in urban and rural, but semi-urban it's pretty low. Okay. So always remember you have to interpret the graph well as well. Okay. Cool. Let's look at the instructions again. We have to do a similar task like group the data using two columns, that is education and the loan status, right? Because earlier we did using the particular locations or the geographical areas. Now we want to do it using a education. Okay. Again, similar to that, we are using size and unstack options, which we did earlier. And then we are plotting an stacked bar plot this time. So earlier we did unstacked. This time we have to do a stacked one. Name the x-axis, name the y-axis, and rotate the label for 45 degree. There are a few questions which you might want to get into is like, overall, which group has asked for higher loan services, irrespective of the approval, graduate or non-graduate. So basically this helps us understand whether the higher educated people ask for a more loan or whether the people who are not highly educated ask for a more loan, right? So you understand your customer pattern. Which group has had better approval to non-approval ratio, which is very important to understand as a group wise. Whether are we approving more loans to the people who are highly educated or not educated? So is our model biased or is our data biased, right? Do the above conclusion makes any sense and why? So this kind of questions you might want to get into once you do the visualization. Can we try quickly? Because I think it's pretty much similar to what we did in the last question. All right, Nikhil is already done, it seems. Yep, he's done. That's good. That's good. Devendra is also done. Wonderful. So Devendra, Nikhil, can you get into these questions? Can you see if you can maybe make interpretation in some extent?
Yeah, we are trying.
Yep. Anybody else? All right, that's awesome. That's awesome. Again, guys, it's one and the same line on the code that we have done earlier. Earlier, we do a group by on the two columns, that's education and loan status. Put that into a list because we are using two columns for the group by. Find the size and unstack it so that the column, sorry, the row becomes the filter column for us. Then again, we are using the same strategy where we are using directly the data frame dot plot. Kind is equal to bar because we are going to use the bar graph. What has changed from the last example is here we said stacked is equal to false. Here we are going to say stacked is equal to true. The fixed size remains the same. We provide the X and the Y label. right? So if I plot it now, I just get two, one, the graduate and the not graduate. If I say stacked is equal to false, sorry, the stacked is equal to true, I get two graphs stacked on each other. So if you see here, the loan set is y and n, I have two values, but it's colorly differentiated and put it on one or the other. I can utilize the same one which we did earlier. I can say false. And I'll get two different. For graduate, I'll get two. For non-graduate, I'll get two. Okay. Or I can simply say true here. All right. So that's the, I think, only difference what we have from the last one. Right. So I think Devendra also has got answers for the questions. Seems overall graduate asked for a higher loan services. That's absolutely right. So people who have a more education, right, is going to ask for a better loan, sorry, more number of loans. And the graduate has a better role approval ratio, right? So again, maybe makes sense because they have a more, or I think say a good credit history in a way, right? They are more reliable. So that's why you might see a higher loan approval ratio. Right. So that's all about the bar chart. Again, guys, realize it when you want to put up a bar chart. The one variable has to be the categorical, the second has to be the continuous variable. Can we change the color of graph? Absolutely, you can. I think there is something called as color, if I'm not sure. Let me show you. There is a let me tell you the color. This is what we call as beautification. Is there a color? I don't think so. It would be color in one argument. So black. Maybe I can put it into a list saying that black, white. So there's an argument called color that I'm sure. Prasad, is that the answer you were looking for? So there is something called an argument called color, COLOR. If you just want to use one color, so just give one color. But if you want to give two colors, like we have utilized two colors, so I think it's in the list that you should pass. So I'm just saying black, red. So the no was given to the black, Y is given to the yes. So it got changed. And if you want to keep it maybe default one, just get rid of it. Yep. Any questions, guys? So I think there are more, just two questions. So let's break for 10-15 minutes, then we can come back. Yep. Yeah, guys. All right. Hello guys, is everyone back? All right, cool. Let's look at the last two set of questions that we have for today's one. The first one, the smarter and the richer, right? After seeing the loan status distribution, let's check whether being graduate or not also leads to a different loan amount distribution by plotting an overlapping density plot of two values. So basically what we are trying to understand here is whether am I graduate or not graduate, does it make any difference or does it influence the amount of loan that I can get? Is that clear? So if I'm graduate, will I be eligible to get more amount, or if I'm not graduate, will I be not getting a higher amount of loans, right? So what we have to do is create a data frame called graduate, which is a subset of the original data source that we have called data, right? So create a data frame called graduate, which is a subset of data frame data with a condition that data, so that is the name of the original data source or the data frame, education is equal to graduate. So what are we trying to do here is, anyone, any quick idea? What are we trying to do here is, we are filtering the records where the graduation, sorry, the education is equal to graduate. Is that clear? Similar to that, we are going to create another data frame called not graduate. And here we will apply the filter condition that education is equal to not graduate. Plot a density plot loan amount of graduate amount or data frame using series dot plot kind is equal to density, and then do the same for the not graduate. And there are some questions we can talk about is, do graduate people get approved a higher amount than their non-graduate counterparts? What is the average amount of loan approved for graduate on the non-graduate? Is there a huge difference between the two? Is everyone clear with the question that we have posted here? Anyone, any doubt? What is the question? Yes, guys. Is everybody clear with the questions? What we have to do? Can we try it if the question is clear, guys? At least can we try the first two sentences where we are creating the subset of the data frame from the original data source? Can we try it quickly? Yep. Anybody got the result? All right. So what we have to do in this question is primarily do the filtration of the records which satisfies the condition on one of the column, right? So what we're trying to do here is we're trying to filter the records where the column education has the value graduate. Okay. So simplest way to do it is data education, that is the column, equal to graduate. But let me try doing that and see what is the result that we get. I don't know how many of you tried it, but let me do it. So I simply said data, that is the name of my data frame, column education equal to graduate. So, okay, oops, I'm sorry. So the result that I get is in the Boolean condition, true, false, true, false, true, false. Correct? But do you think that results makes any sense to me? Can I interpret the result? Can I get the other rows as well? No, right? Because it just results into true, false, true, false. So what I have to do is I have to pass this true, false to the original data frame to filter the records and show the records whenever the value is true. Is everybody clear with this distinction? Anyone has any doubt on this? Why are we using this comprehension and what does it mean? Yes, guys, any questions on this? Quickly. And that's what we did. So we first did the graduate. Okay. So Kamlesh, the first requirement for us is to identify the records where the column education has a value graduate. Is that right? So I can simply say data, that is the name of my data frame. Select the column education and look at the value that I want is equal to graduate. However, when I execute this, I get the result in true, false, true, false. Is that clear, Kamlesh, for this particular step? But can I utilize this value true, false in any constructive way? I cannot, right? Because I'm not able to interpret what this true means and what this false means in a way on a broader sense. I'm also not getting any other columns other than just education. Is that right? So what I can do is I can pass on this true value or false value to my data frame enclosed in this fashion. So now what will happen is instead of this line, I will get this. Does that make sense? Because this condition will evaluate to either true or either false, right? This condition will either evaluate to true or either evaluate to false. So wherever there are true, only those records will show up. Is it clear? So similar to that, we can do it on any columns. So I'm doing it on graduate, I'm doing it on not graduate. Okay. So I get two individual data frames, graduate one, not graduate two, right, which is based on the column values. The next task that is available to me is I have to plot the density plot. Does anybody know what is density plot by any chance? Does anybody know here what is density plot? Okay. So density plot primarily showcase you the distribution of your data. Okay, I'll repeat again. The density plot helps you visualize the distribution of your data, right? Whether your data has a normally distribution or whether the data that you have is skewed data. So what do I mean by skewed? So in statistics, in basic statistics, we have a distribution of data. Okay. So your data can be normally distributed where you have this bell curve. Okay. So that satisfies the statistical condition that mean, mode, median is equal. Okay. Let me show you that maybe in a graphical way helps you that. Density plot. So density plot is a representation of the distribution of numerical variable. It uses the kernel density estimate to show the probability density function. Okay, so let me show you one more thing. Data distribution types. Okay. I don't know, this might be over education, but so this is what we mean by a standard distribution. Okay. Your data is normally distributed. There is no outliers. There is no any value which is about the range, right? So I have a proper bell curve shape where the mean would be at the center and the data is equally distributed. So a normal distribution is a distribution where the left side of the mean and the right side of the mean generally equalizes. I mean, they're both the same number of records and the same distribution. Okay. And there is something also called as this, right? So this is not a normally distributed data, right? There is a highly skewed towards the failure, correct? So the data would look like this. Do you think this is normally distributed? Because I have a highly skewed data towards my left and there is absolutely nothing towards the right. So this is what we call as a right skewed data. Okay. However, this is my normally distributed data. Okay. So this is the kernel density function. That's we were talking about here. So that's the standard normal distribution. It's more of a statistical concept, right? But it's just basic good to understand that what do we mean by skewness in the data and what do we mean by a normal distribution. Okay. So similarly, what we want to print here. So I'm just saying graduate loan amount dot plot. So another method of doing a visualization straight out of data frame is you can choose the data frame name. You can choose any column that you want and you can only do a plotting on it. Okay. Another way. In the first method, we did plt.plot, if you remember. plt.bar, that's one method. Second, we did data frame dot plot. Where is it? Oh, data frame dot plot. The third one is you can select a particular column like we did here. Guys, everybody be on mute, please. In this method, we are directly doing data, then the particular column dot plot. The kind now changes to density. Okay. The kind now changes to density. Similar to I'm doing it for non-graduate, plot is equal to density and plt.legends. So I'm giving legends because I'm using two plots back to back. Okay, so if you see it closely here, the not graduate data has a high stiff and then it curves down. This is what we call as curtoness is what we call here, the sharpness of the peak. And then I have this line for the graduate one, right? So can you tell me if any one of this follows a normal distribution by any chance? Do you believe any of this has a normal distribution? Absolutely no. None of them have a normal distribution. So basically, the KDE plot or the density estimation plot helps data scientist or a data analyst to understand how this particular column is distributed. By looking at it, I realize that my column loan amount is not normally distributed and has some of the outlier amounts or has some of the data points which is not in the normally distributed fashion. Second, I realize immediately that there is a high number of imbalance between between the graduate and non-graduate, right? Because I see there are very less number of data points or less number of records for not graduate. Does it make sense, guys? Because I just have a very short span of a graph for a not graduate. However, for graduate, I have a very long tail span. So that clearly indicates that the number of people who are graduate are more enough than the people who are not graduate. So it's a imbalanced data set that I have on this front. Correct? Does it make sense, guys? Is everybody clear, guys? What are we trying to do? Yep, it is not a balanced data. Definitely not. So if you see here, density plots are used to study the distribution of one or more variables. Checking the distribution of your variable one by one is probably the first task you should do when you get a new data set. Okay. So it explains the variation as well, right? So any quick question, guys, on this? What do we mean by density plot? Density plot and a histogram has a very much similarity between them. So I can show hist. So if you see here, for graduate, I am printing the histogram. What does an histogram shows? In the school, we have all learned what is histogram, right? So it shows the distribution. So histogram and a density have a very similarity between them. Are you all clear, guys? Any quick question? How will we know? Well, Nikhil, the ideal answer is two things. One, you need to understand the data well. Second, experience. Because as I said earlier, you will use bar plot when you have one categorical, one continuous value, right? What if you have both continuous value, like if you want to print income and loan amount, right? So it is imperative that you understand what is the type of data that you're working on, correct? So if you
Yeah.
have both as a continuous wave value, you will use a scatter plot. Okay. If you have one continuous, one categorical, you can even use a pie chart, right?
Mhm.
Or you can even use a line chart. So you won't understand, you won't get it in the one go, that's for sure. So you need to, spend good amount of time understanding how the two data points can be visualized in an effective manner. Okay. There are some, thumb rules, like as I said, two continuous datas would be go into scatter plot, continuous and categorical go into line or bar plot. So those are the rule of thumbs. Okay. But definitely there are so many plots, there are so many graph that comes every day in, every day out, that you need to understand which is more useful in your data that you're using.
So it's basically with the data which we are reading the data and plotting that one, and the data is continuous. So we'll do some continuous diagram and histogram like that. And if it is finding the average of that, then we'll test density we have to make. And if it is a yes or no value, then it will be like a bar chart.
So it's not about yes and no value, it's about the categorical value.
Yeah, sorry, category value. Yeah.
So If you have a distinct number of categories, then yes, you can go with the bar plot, or you can go with even pie chart, if that
Mhm.
makes any sense for you. Or if you have two continuous, the last example that you're going to start now, this one. Oops.
So donut and the pie chart are similar then, right?
It's a donut is nothing but a version of a pie chart. That's it.
No, I used in the JS, so that's why.
Yeah.
Yeah.
So now if you see there are two scatter plots. Why scatter? Because on the X and the Y, I have a continuous way of values,
Yes,
right?
yes.
So my point of saying is, as and when you practice more,
Mm-hmm.
it's easy to come by that, okay, I have a two categorical values. How can I print it? How can I visualize it? So the easiest way, what we used to do in the early stages, is take a paper and pen, right, and simply try to visualize what would you print on the x-axis and what would you print on the y-axis. Okay,
Okay,
that
okay.
helps. That helps in a real great way.
Hands-on
Now,
will be there. Yeah.
yeah, I mean, now what has happened is, I mean, the time has changed such drastically. Nowadays, we have a tools like Power BI, ClickSense, ClickView, Tableau, right? These tools were not there back in 2010 or 2011. These tools have just emerged as the new industry now. So people who knows here Power BI, people who knows here Tableau, they know how easy it is nowadays to do visualization. It's just a matter of drag and drop, correct? You just select any chart that you want, you drag it and you drop it on your canvas. The tool internally will create the graphs for you, isn't it right? Right. I see some people who are doing Power BI earlier, right? That's how easy it is. Okay.
Yeah. Correct.
But yeah, it's just a matter of time that you spend. There are wonderful visualizations that people have created. You can go and visualize. So there is something I can show you if you want to study. So go to Tableau experiment. Tableau sample dashboard, I think. So public.tableau.com is the website. It might take a little bit. So if you see here, sample sales dashboard, and it's available for every leading tool. So if you see here, the line graphs, this is a geolocation graph. This is nothing but a bar chart again, all right? It just the horizontally put it up.
Yeah.
This is again a bar chart, stacked one, right?
Yeah. Correct. Structure. Yeah.
Here is a scatter plot. So yep, you can just you can. I mean, what I generally do is if I want to get a good idea, look at some of the dashboards that people have created around the world. It gives you a good idea, right? That what to print, what not to print, something like that.
So it will give us a fundamental idea about the which.
Yeah, definitely. I mean, what the data industry is so
Mhm.
close and so collaborative that if you're stuck somewhere, if you want new ideas, there should be someone who has already done it for you, right? So just think about it, and maybe you'll get a good idea that how you do it.
Mhm.
So I mean, this type of charts that you see here is definitely not possible in Python, right? It's primarily coming from the different tools.
Okay. Uh,
So
yeah.
this is coming from Tableau. There are a few other things that will come from a ClickSense. I mean, this kind of effect is definitely not possible if you talk about any language. So if you look at it, this has a what in particular
Geograph.
map. But can I like I have a provision I can zoom in, right? See, I can do that definitely in Python. This responsiveness is not available in Python. The moment I select this part of the country, every chart that is associated with this geolocation gets affected. They change their values as well. So if I deselect it, you can change this line will change because in the background the data got reflected. See, does it change?
Okay. Hmm.
So this is what we call as an responsive UI. It is responding to your actions. That's what we call as responsive UI.
Without
So
referencing the page.
exactly. So the responsive UI came into the market when people started talking about Tableau, ClickSense, Power BI, right?
Okay.
Yes, you can do it in Python for sure.
Okay. Okay.
Python, what we are looking at in this visualization is helpful for maybe, the data science world, the ML world, where I am a data scientist, okay, and I got the data set for the first time.
Okay. Mhm.
I can't go to the Power BI and upload clients' data straightforward without their consent,
It's the bridge of.
right? Because I can breach the data security violation and all that stuff.
Okay. Okay.
But I also have to understand the data before I start doing feature engineering or maybe the modeling part. So what I do is I quickly utilize Seaborn or Matplotlib and quickly come around with some density plots, histograms, scatter plot to understand the relationship and just move on.
Mhm.
Okay.
Yeah. Thank
I hope I maybe answer your question.
you. Yes, I just have to understand how to understand this bar plot, all the things. But yeah, better get the knowledge over the data, how to analyze that one.
Exactly.
Then
Exactly.
we'll get to know that. Yeah.
Exactly. The moment you understood what is the type of the data that you're working, half
Hmm.
of the challenges that you might even face will be resolved.
Yeah, that is fair. Yeah.
All right.
Yeah. Thank you.
Cool. Okay, with that, let's look at the last question in the session today is income versus loan. I mean, this is the most important question any company would ask. All right. So for any financial institution, which is real, any financial institution to be successful in its loan lending system, there has to be a correlation between the borrower's income and the loan amount. So that's true, very right, correct. In the real world also, the loan amount that you would get has a direct correlation with the amount that you earn, right? In this case or in this question, what different we are going to do is we are going to work with the subplots. So the subplot primarily means we want to create the plots together in a fashion that they represent similar information. Okay, and we're going to see how the subplots are primarily created in Python. Since both are continuous variable, like what we are going to work on is applicant income, loan amount, right? So these are both continuous variable, continuous amount. Set the excess title as applicant income, plot the scatter plot between the co-applicant income and the loan amount on the second figure. Create a new column in the data frame called total income, right? And then utilize it to find out the relationship between the loan amount. Okay. What is the question we are going to look into is there a correlation between applicant income and loan amount? Is there any correlation between the applicant income and loan amount? Or the way to know is whether looking at the line found when you connect the scatter plot dots. So basically find out the correlation between the two variables. Is the total income better related to the loan amount than applicant income? So this is another question from the feature engineering world, because if you realize in the data, we have a two different columns, right? We have applicant's income, we have a co-applicant's income. So the question is it better to utilize only applicant income with the loan, or should I utilize the summation of applicant plus co-applicant income and then look at the relationship with the loan amount? Is the question clear, guys? What are we planning to do? Any confusion? Okay. So let's first figure it out. How do we create the subplots? Okay. So there is a function in the matplotlib library called plt dot subplots. So it allows you to create the number of different but parallel plots which you can individually work upon. Okay. So I'm saying PLT dot subplots. Now it expects you to provide three inputs. So the first input is the number of rows that you want to create. So I'm saying 1. The second is the number of columns that you want to create. So I'm just saying 3. And then the individual figure size. So 20 by 8. So let me show you what I'm actually pointing it out. Oops. So I'm saying 1 row, 3 columns. So how many plots I'm getting here? The 3 different blank plots I'm getting. Is that clear?
Yes.
So if I say 2 by 3, how many plots do I get?
Two rows,
Two
three
row,
columns.
three,
Yeah.
three
That's
columns.
6.
Right? So do you understand what this first 2 argument means?
Yes.
It 2 means simply the number of rows. 3 means simply the number of columns. How many number of total plots will I get? 2 into 3, 6. Are we clear? Okay.
Yeah.
What does fixed size means? It simply denotes what is the size of individual plots you want. So I'm just saying 20 by 8. I can even say 10 by 8. So it will be pretty small, right? So 10 by 8. Are we all clear, guys? What we mean by here? So 30 by 8 would look like this. Now, if you closely observe, this plots that I'm getting is the blank plots I'm getting, isn't it? There's nothing in there. They're just the blank plots. And if you closely observe, I'm getting array. Excess subplot, excess subplots, excess subplots. Can anybody make a wild guess? What does it mean? Yeah, guys? Anybody?
Small subplots.
Yeah, it is. But the subplots is returning to me an array object,
It's stored in the list area.
which
Actually.
simply means I can utilize this objects to make the changes in appropriate graph. Are you getting my point? It is giving me an object in the array format, which simply tells me if I want to modify any properties of this graph, I can utilize this object and do it easily. Similarly to this, similarly to this, similar to this, and go on. Okay. So that's what this line is doing here. PLT dot subplots, 1 row, 3 column with this figure size, and look at the return type it is giving to me. First, it is giving me this figure object, figure size. So this figure object is concisely this all together, consolidated object. Okay. So that is what we are saying here, fig. So fig is nothing but the consolidated object for me. Then I'm saying AX1, AX2, AX3. What does it mean by AX1, AX2, AX3? Anybody? Quickly, what do we mean by AX1, AX2, AX3?
Those are objects to refer to individual subplots.
Absolutely right. Those are nothing but the objects that will allow me to modify this particular graph individually. Okay. So that is the return type that I'm getting here. Now look at it what I'm doing here. I'm saying AX1. So AX1 means the first plot. Correct. So I'm saying AX1 dot scatter. Right. So I want my first plot to be a scatter plot. So AX1 dot scatter. Now scatter will need two things. First is x-axis, second is y-axis, correct? So I'm simply saying data, applicant income, data, loan amount. So anything left to this comma would be an x-axis. Anything right to this comma would be a y-axis. Okay. So I'm simply saying ax dot scatter. On the x-axis, show me the applicant income. On the y-axis, show me the loan amount. Are we clear, guys? What are we doing here? Any questions? Yeah, guys, quickly. Okay. Similarly, I can do for the second plot. I'm saying ax2 dot scatter, right? Data. Now I'm using co-applicant income instead of applicant income. Correct? So co-applicant income and the y-axis is the same loan amount. So that's why I'm getting this way. Correct? So it is clearly visible that the applicant income has a clear linear relationship to the loan amount. However, co-applicant income has not very strong, but still a similar linear relationship with the loan amount. Are we clear, guys? Can you interpret this graph? If you look at it, the amount my income is increasing, the loan amount is also increasing. This high points is showcasing both on the higher nodes, even the loan amount similar to my income. Even in this case, when the amount is increasing, my loan amount is also increasing. However, there are some outliers I can see in the co-applicant income, where their income is zero, if you look at it this, but their loan amount is pretty high. Do you all agree with these observations? So this is the power of visualization. Without even looking at the data, without even going inside the data, I can get the real nice picture of what my data is returning to me. Is it clear, guys? What are we trying to say here? Yes, guys, are we clear? What are we saying here? The last part that we had in our instruction was total income. What is total income? Well, it's pretty simple. Total income is nothing but if you see here, I'm creating a new column, data, total income. It is simply the addition of two, the applicant income plus the co-applicant income, correct? And I'm putting that into a third graph, x3 dot scatter. X-axis would be total income, y-axis would be loan amount. And if I now put it up into the graph, I can see a very clear and a nice linear trend here, right? It's purely a nice linear upwards trend that I can see. The moment the income goes up, similarly the loan amount goes up. I can go and even make the changes to the scatter plots, x-axis to the every individual graph. The reason I am able to do that because I get individual object of every graph, every plot. Are we all clear, guys, what we did here? Any questions? Any confusion? Can you all try to implement the last one? Important is, guys, do we understand what do the subplots do? You guys, are we done? Categorized by the requirement data visualization. I'm sorry, Nikhil, I didn't follow.
Mm, I just understand in the simple logic that when we are using this subplot for that, so we are just representing different data and just tweaking the data and plotting different type of graphs.
So basically, I'll tell you when we use subplots, all right. If you see here, if you closely observe, the applicant income and co-applicant income is a relatable information with each other, right?
Correct.
And I'm comparing this two relatable information with a common column called loan amount. Correct.
Yes. Yeah.
So whenever you have this kind of requirement where you are trying to visualize the relationship between two relatable columns, okay,
Okay.
then you can
Okay.
use a kind of a subplot.
Hmm.
And subplot always plays a very huge role because it in a short span it gives me a huge information, right? So and it is because it is standing next to each other, I can easily compare, right? Now I can compare here that applicant income does not seem to have any outlier, but co-applicant income definitely have some outliers.
Yeah. Data comparison is very much
Exactly.
easier.
And surprisingly, we have not even yet touched the data. We have never seen the data, right?
Correct.
So when you give this to your stakeholders or maybe your client, you don't need to go into the data and showcase the story. You can just build a story from this plot itself.
Okay.
Yep. Are we done, guys? Any questions? That you will use subplots a lot, and you should use a subplots in a good amount of work. Yeah, guys, are we done? I mean, this was the last session we have for today. And we are not even scratching the surface, guys. The visualization is a far big topic to cover. Are there any questions before we close the session, guys?
Puneet,
Yeah.
so can you just, in a short, can you just explain this last one because my network hasn't just lost, so I didn't get that much in the plotting, the last example.
So here we are trying to plot multiple graph in a single visualization spec.
Okay.
Okay. Earlier, whatever we have been doing is just one graph at a time.
Exactly.
So there is a inbuilt provision called subplots.
Okay.
Subplots will take three arguments. The first one is the number of rows that I want to create. So this is the one row.
Okay.
The second argument it will take is the number of columns.
Columns.
So I have three columns.
1, 2, 3. Okay.
So the total number of graph that will be built out of it is 3 into 1, 3.
1. Okay.
The last argument that I will pass on is the fixed size, which basically determines what is the size
Length
of individual plot that you want.
Okay.
Okay. Now it will return to you two items. One is the overall object of the figure, so the entire figure.
Okay.
It will also return to you the individual objects element.
Okay.
So as I have created three different plots,
Okay.
I get three different objects of it.
Okay.
Okay. Now, as I get three different objects, I have a free hand. I can create any type of graph I
Okay.
want to the individual plots. I simply say AX1. So when I say AX1, I'm referring to the first graph.
Okay.
I'm simply saying AX1 dot scatter. Okay. So I'm passing two elements. One is the applicant income, which will go on the X axis,
Okay.
and I'm plotting data loan
Loan
amount, which will go on the
y axis.
Y axis.
Okay. Clear.
So that is the first plot I just created.
Okay.
Similarly, I'm accessing the second plot now, AX2.
Okay. Clear.
The X axis would be the co-applicant's income.
Okay.
The Y remains the same, that is loan amount.
Okay.
On the third part, what I simply did is I created a new column, total income.
Okay.
I just did the summation of two,
Okay. The applicant and
the
co-applicant.
applicant income and the co-applicant income.
Okay.
Okay.
Okay. Understood. Understood.
All right.
And in the third, you
I just plotted the total
Hmm.
income,
Okay.
the newly created column. With the Y remains the same again.
Against.
That is the loan amount.
Now the x will change. X will take the combined value of the
Exactly. My X got changed to the total income.
Okay.
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 So I can have a clear relationship identification that which of this has a more clear relationship towards the loan amount,
No, no.
whether the individual incomes of the applicants or whether the combined income
Combined.
of the individuals.
Clear. Clear.
All right.
Yeah. Clear. Thank you, Puneet. Thank you.
Yep. Sure. Sure. Any more questions, guys?
Yeah, Puneet. So, looking at the scatter, uh, hello.
Yeah. I'm listening. Go ahead. Go ahead.
Yeah. So, looking at this scatter, Puneet, uh, like total income or applicant income, like which one is more sensible?
Okay. What do you think? What is best according to you?
Uh, I mean, like I don't have knowledge on the
No,
scatter.
I'm
Yeah,
just asking. What is your gut feeling says?
yeah. I think total income is a good indicator.
Okay. And why do you believe so?
Mm, because there is some uniformity. I mean, if I compare applicant income and total income scatter, uh,
Mhm. Well,
then there is.
your answer is absolutely correct. Okay. When you look at this kind of a scatter plot or when you look at this kind of relationships, it is quite imperative that you will go and select the total income as your indicator. Okay. For quite a variety of reasons. One, I see a clear trend in the total income's relationship with the loan amount rather than looking at the applicant income. Okay. So I have a clear relationship between these two if I compare these two. Second, if I take a total income as my indicator, it also covers the diversification I have in the co-applicant's income as well. Because if I consider this point, which is a total outlier, it seems in this case that co-applicant is not earning anything, right? Because that was the zero.
Mhm.
So maybe a sleeping co-partner, what we say in the loan account, right? But he's
Yeah.
still getting that loan amount because he's getting dependent on the applicant income. So domain wise, it makes sense if I combine both of them income.
Mm.
So the answer is correct. We will go and select. So how would you select these based on the case to case or domain to domain? But in this loan application, I can clearly say that it is good idea that I combine both of them income. Okay. So I get a more, you can say, comprehensive view of what is the total income under one case rather than looking at the two different incomes.
Yeah. Maybe we need more. We need to have more experience in reading and reading this
Exactly.
a kind of
Exactly. More
scatter.
important is how
Taking,
you interpret the graph, because
yeah,
that is where the entire story lies. Okay. You have to interpret the graph well, because if you don't interpret the graph well, then creating the graph doesn't solve any purpose.
yeah.
Okay. Can you please explain density graph? What exactly you want me to explain, Akshata, in density graph? Because I think we have pretty much covered it. All right. Anyways, I can give you an overview again, right? So I can share this link as well if you would like. So density plot again is a helpful plot when you want to see the distribution of your data. Now, what is distribution of data? Well, it is a statistical property which helps you understand how much your data is spreaded. Okay. How much your data is spreaded between the data, sorry, between the ranges. So if you look at it in this particular area, my data started from this point and I'm moving towards the normal distribution. So this is the one way my data can be distributed. Other can be my data like distributed like this way, where I have a lot of bumps and a lot of ups and downs. So there is no uniformity. There is no what you can say a good distribution strategy. The lot of spikes, lot of downs. Are you getting my point, Akshata, by any chance? These are all statistical properties that the distribution of my data is not normal here. I have a lot of ups and downs, right? But if you look at this one skewed, I have a lot of data points at the beginning of my distribution, but then I don't have anything at the end of the part, right? This is another way of distribution. This my data can be in this format as well, where I have a lot of data points in the beginning, but I don't have anything at the end. Or I have something like this as well. I have one hike, then I have one total downfall, and then I have another hike. So the point of say showcasing all this is these are some of the ways in which your data can be distributed, your data can be available. And how you know how you plot it is using a density plot. Because the way your data is distributed, it impacts its further action on the modeling part or the data science part. Because if your data is available in this format, then the actions are different. If your data is available in this particular format, the actions are different. And if the data is in the normal form, the action is different. So it is imperative that we understand how the data is distributed. Does it make sense, Akshata, by any chance? All right, cool, thanks. Yep, any more question, guys? Okay, I think if there are no more questions, then I think we can close the session. Yep. Thank you so much, guys, for joining in. I hope the session was good, informative. You learned something new. Please feel the feedbacks so that we can know where we can improve. Okay. See you tomorrow with the new topic. Keep yourself safe. Keep practicing, guys. Thank you so much. Have a good day ahead.